Hello students, welcome to your YouTube channel Mathematics for Everyone. In this video we shall take urgent plane and polar representation of a complex number and also take some more important questions relating to complex numbers. First of all we take urgent plane and polar representation. We know that corresponding to each pair of real numbers corresponding to each pair of real numbers x, y, we get a unique point. We get a unique point in the xy plane. In the xy plane and vice versa. That is for every unique point we shall get a pair of real numbers in the xy plane. This is vice versa. With the reference to a to a set of mutually perpendicular lines called x-axis and y-axis. The complex number x plus iota y, which corresponds to the ordered pair xy can be represented geometrically on the unique point pxy in the xy plane and vice versa. The plane having a complex number assigned to each of its points to each of its points is called the complex plane, is called the complex plane or origin plane. Let us draw figure. This is x-axis x-axis dash, y dash. This xy plane O is the origin and x-axis y dash are two mutually perpendicular lines. This is origin 0, 0. In the origin plane, the modulus of complex number, the modulus of complex number x plus iota y is equal to square root of x square plus y square is the distance between between the point P x y and the origin O 0, 0. Now there is point P x y which corresponds to the complex number x plus iota y. This is square root of x square plus y square. Plus if we draw perpendicular line from this is y and this is x. OM is x and PM is y, this by coordinate geometry. The points on the x-axis, the points on the x-axis the points on the x-axis corresponds to the complex number correspond to the complex number of the form x plus 0 iota, that is x0, and the points on the y-axis and the points on the y-axis corresponds to the complex numbers correspond to the complex number of the form 0 plus iota y, that is 0y. In the urgent plane, or complex plane, x-axis is called the real axis. X-axis is called the real axis. Why? Because in this case, the points of the form x0, that is, which have only the real part, imaginary part is 0, which is only real part which has, so that's why they are called real axis. And y-axis is called the imaginary axis. And y-axis is called the imaginary axis. Because the points lying on this are of the form 0y, in which the real part is 0 and the imaginary part is y. So here x to x dash is the real axis and y to y dash is imaginary axis. In the urgent plane, the representation of a complex number, the representation of a complex number z is equal to x plus iota y and its conjugate z bar is equal to x minus iota y are respectively the points pxy and qx minus y. Geometrically, the point pxy, is the mirror image of point qx comma minus y on the real axis. On the real axis means x to x dash, x-axis. Therefore, if we have this is real axis x to x dash, this is imaginary axis y to y dash. Therefore, if this is point pxy, then its image with respect to real axis x to x dash is qx minus y. These are the images. So this is What about the Argand plane and polar representation? Then we take some questions. First question, if alpha and beta are different complex numbers with mod beta is equal to 1, then find absolute value of beta minus alpha over 1 minus conjugate of alpha into beta. Solution. To evaluate this, first of all, we shall find square of beta minus alpha over 1 minus conjugate of alpha into beta whole square is equal to beta minus alpha over 1 minus alpha bar conjugate of alpha beta into beta minus alpha over 1 minus conjugate of alpha beta whole conjugate. Since z square is equal to z into conjugate of z. Now we multiply these. Before multiplying, we take conjugate beta minus alpha over 1 minus conjugate of alpha beta into conjugate of beta minus conjugate alpha over 1 minus twice conjugate of alpha is alpha into beta conjugate is equal to, we multiply this, beta conjugate minus beta alpha conjugate minus alpha beta conjugate plus alpha conjugate over 1 minus alpha beta conjugate minus alpha conjugate beta plus alpha conjugate beta into alpha beta conjugate is equal to, now beta conjugate is mod beta square minus beta alpha conjugate minus alpha beta conjugate plus alpha mod whole square over 1 minus alpha beta conjugate minus alpha conjugate beta plus alpha conjugate is mod alpha square, beta conjugate is mod beta square. Now we have beta square is 1. 1 minus alpha conjugate beta minus alpha beta conjugate plus mod alpha whole square over 1 minus alpha conjugate beta minus alpha beta conjugate plus, now mod beta is 1, so it will be left with this. So we cancel this, this is equal to 1. Therefore, mod, we take mod beta minus alpha over 1 minus alpha conjugate beta mod is equal to 1. This is the answer. Then we take second question. If 1 plus iota over 1 minus iota whole raised power n is equal to 1. Then find the least positive integral value of n. Then find the least integral value of n. Solution: we have 1 plus iota over 1 minus iota raised power n is 1. Then we rationalize this 1 plus iota over 1 minus iota into 1 minus plus iota over 1 plus iota raised power m is equal to 1. 1 plus iota square plus 2 iota over 1 minus iota square whole power m is 1. So this will give you 1 minus 1 plus 2 iota over 1 plus 1 raised power m is 1. It implies 2 iota over 2 raised power m is 1. Iota raised power m is equal to iota raised power 4. Therefore m is equal to 4. So that's all. In the next video we shall start a new chapter, mathematical induction. So please don't forget to like, share, comment and subscribe to your YouTube channel Mathematics for Everyone to see more important videos. Thank you. See you in the next video.